Hello, everyone, and welcome to the third and final day of IO Extended UK and Ireland. Okay, so before we begin, I'd introduce myself. I'm Hina from GDG Dublin, and I'm joined by two others.
Hello, I'm Mamta Gilani. I'm the co-organizer for GDG London. And we have Fahad here. Fahad, you want to introduce yourself?
Fahad, you're on mute.
Sorry, yeah, classic. Hi, I'm Fahad. I'm from GDG Bristol.
Okay, wonderful. So, what do you like most about the virtual events, Mamta?
Um, Accessibility, I guess, because if you are anywhere in the world, you can just come into the event by tapping off one button. So yeah, that's really good about virtual events. But I won't mind physical events now because it's 1.5 year, and I want to meet people in person.
Absolutely, absolutely. And what about you, Fahad?
Yeah, same thing, really. Being able to just attend events, but also, I guess, as organizers, we can also invite people who wouldn't usually be able to make it to these events, and so it's really nice having a more of an option there.
Oh, I can share two things. The thing I love the most about the virtual events is getting a chance to interact with, network with people across different time zones. With in person events, we were just restricted to one time zone, but virtual has opened so many doors. But the one thing I dislike is I can't see any faces. It's like I'm talking to the screen. And it's a little scary. But, anyways, so people, IO extended UK and Ireland. Let's bifurcate the name, what it means. So, every year at Google IO, Google announces new technologies for three days. It's a 3 day event with multiple information. So, at IO extended events, we have bite sized information distributed to you with multiple speakers and their talks. UK and Ireland, so we are a group of Google developer groups that have come together to put this event together of 30 speakers, 9 tracks, and 3 days. So today is the last day for this event, and we have 3 tracks today. This is mobile track, and we also have UI, UX, and DEI, diversity, equity, and inclusion track happening. We'll have 3 talks on each of these tracks. So before we go ahead, we have a small clip to introduce you to Google developer groups.
Technology brings us closer together, even when we're far apart. Google developer groups host meetup events for local technologists to connect, learn, and grow with others in their area.
The project I'm mostly proud of would be teaching introduction to programming to 7 girls in my hometown.
In the GDJ, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of the community members a lot. So I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to a developer and the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.
Okay, certain goof ups also happen in the virtual events. So sorry about that. Google developer groups are local, online, or in person meetups for developers to connect. These are global. And do you know how many GDG groups we have worldwide? More than 1,000. So, everyone and anyone interested in tech, from beginner developers to experienced professionals, are welcome to join. It's a developer community program supported by Google and Google developers. For the developers, by the developers. So we all are volunteers here. We have our own jobs, but we like sharing information with you people. We like to interact with you people. So yes, for the developers and by the developers. IO extended events are organized by Google developer groups across the world, as I mentioned earlier. So, this is a follow up of the Google I/O event that happened for 3 days in the month of May. And then extended events discuss all those technologies that are announced at the I/O event worldwide by different GDG groups. So, what do you think about these I/O extended events, Mamta?
It's a great event to get to know about like whatever that's released for the Google I/O. So Google I/O is kind of like highlight of the year, where you learn about what's new in all of the technology, either it's a cloud or it's mobile or it's a Firebase. So it's really easy to come to the events and just learn about whatever the new concepts or new features that's released by Google. And at the same time you can have a collaboration with other developers, like how it can benefit you, where you can use it. So yeah, it's basically the educational.
Yeah, absolutely. And you do not have to be an expert if you want to talk about at any of these events. You made something, you made a project, and you want to share it with the world, you're more than welcome to come and talk about it.
Yeah, you can just come and say like, okay, I really don't know anything about it, can you just tell me?
Absolutely. So we had all these tracks over the period of 3 days. And today we'd be having the mobile track on this stream. Some housekeeping rules. Please be kind to each other. Don't abuse. And we are our host for today. I am co-organizer for GDG Dublin chapter, joined by Mamta from London and Fahad from GDG Bristol. Code of conduct, which explains the same thing: be nice to each other, be kind and not abuse, and share knowledge. Enjoy the most of the sessions today. We have amazing talks lined up. Totally excited about all three of them. And what do you say? The timing, the right timing. Compose just became stable yesterday. The 1.0 version, the stable version is released yesterday. So I'll hand over to Mamta to announce the agenda and take it ahead.
Yep. So this is more interesting, right? So what's happening for today? For this past 1.5 hour, what we're gonna do? We're gonna learn a lot of stuff about Jetpack Compose, which basically, as Hannah mentioned, just released yesterday, and goes to stable version 1.0. So that's really exciting, and that's good because we have event on the next following day, and we have amazing speakers today. So first, we're gonna go to adopting the Jetpack Compose. After that, we're gonna go to the second one, which is using the Realm in KM project with Jetpack Compose and Swift UI. And the third one is a bit interesting, and hopefully you wanna stay till the end because it's a FOMO in Android. And I'm not sure if you've heard about it, if you've felt about it, but yeah, we're gonna talk about it today. During all of these sessions, if you have any other questions, the live stream is open. Feel free to put all of your stupid questions over there too. And yeah, no question is a stupid question, in my opinion. So we'll take all of these questions at the end of the day by all of the speakers, and then we will wrap up the event. So that's the agenda for today. And we can move to the next slide. Before we go there, so this will be the fun. You're gonna talk to a lot of people, and you're gonna have a lot of funny moments. So be social, be share. You can use this hashtag, and whatever you feel about the event or the content or the speaker, or you just want to say thank you, feel free to do so using the Twitter and this hashtag. Uh, yeah, and we can move on to the next session. Okay, so this is our next session. We're gonna go with our first speaker, which is Joe Bush. I'm gonna add him to the stream. Okay, somebody else did for me. Thank you. And before that, I would like to give a little bit of introduction, because I like introducing, speakers. It kind of gives you the personalized feeling about it. So let me tell you a little bit about Joe. So I'm following Joe for past 5 years since I'm doing the Android development. So he's Android engineer and Google developer expert for Android Actions on Google based, and he's based on Brighton. He's passionate about creating meaningful products, diving into new technology. You can just go through his blog and you can see everything. And helping the community along the way. Outside of the work, he's building Jetpack Compose and also loves to dabble in the electronic project in his spare time. So yeah, this is a fun moment for me, Joe. I really like your Bofferoo clean architecture demo that you put on the GitHub. So yeah, you can just go ahead and introduce yourself.
Cool. Thanks for the introduction. Really appreciate that. It's great to be here today, and yeah, it's great timing to be talking about Jetpack Compose. Yeah.
You can carry on from here.
Cool.
Just gonna go over from now.
Cool. Perfect. Just share my screen. Cool. Apologize for the mess. Having house renovations at the moment, so don't have an office. So I'm currently in the kitchen with all of the upstairs belongings. So yeah, kind of a bit makeshift at the moment, but we can make it work. So yeah, let's do it. So yeah, here today. Thanks for being here. I really appreciate your time. Yeah, as mentioned, my name is Joe. I'm a GD for Android, and with great timing, I'm here today to talk about using Compose inside of existing Android apps. So there'll be some time at questions at the end, and you'll also find my Twitter handle on each slide if you want to reach out there also. Cool. So when it comes to Compose inside of our apps, we're likely going to see one of two cases. So we're either creating brand new features with Compose, so building Compose-only screens, or we might be slotting Compose into existing features, or even using the Android UI toolkit in the Compose-only screens. So in many cases, a lot of developers will be taking this approach and introducing Compose inside of existing apps. In these scenarios, it's unlikely that we're going to be rewriting every single screen from the Android UI toolkit to Jetpack Compose, as tempting as that might be. There will be certain things that might become blockers, maybe road bumps during the process. And while every scenario is different, maybe company focus, team size, current projects, and so on, there are a couple of things that could make this incremental adoption a requirement. So there is still a bit of a learning curve with Compose when compared to how we're used to building Android UI. So it's kind of like a completely different way of building user interfaces that also heavily relies on the architecture of the app, such as state management. There is a lot for teams to adjust to, and also work out how this fits into projects. So while Compose adoption will help us move faster in the long run, we still need to deliver value to our users in the meantime. So dropping everything to adopt Compose might not be a practical approach for most teams. But being able to do so incrementally allows us to do so while still delivering that value to our users. So here it's all about being strategic about how we can still deliver that value whilst also adopting these new technologies inside of our projects. So some things might not be ready or available for us to use in Compose yet. So this means that we'll have to take a hybrid approach in terms of this incremental adoption and fall back to the Android UI toolkit where applicable. We might also have existing views that are maybe not in a position to be converted to Compose yet. So this could be for any reason. So for example, maybe the view is quite complex and require a large amount of work to migrate. That work involved in migration might not be the best use of our time right now. At the end of the day, there could be any number of reasons why we might need to support a hybrid migration. But being able to do so allows teams to move forward with Compose adoption while still being able to deliver value to our users. This unblocks us from using Compose while still allowing us to circle back in future and tackle these other parts of our app wherever the time is appropriate. So in a lot of apps, we're going to end up using composables inside of the Android UI Toolkit and UI Toolkit inside of composables. So knowing about the tools we have at our disposal is going to help us achieve these things smoothly. We're going to start by looking at how we can use composables inside of our existing Android layouts. This can be achieved with what is known as the Compose view. So the Compose view is an Android view class, which is located inside of the Compose UI platform package. At a first glance, this looks just like any other view that we might come across when working with the Android UI toolkit. This class extends from another class, which is known as the Abstract Compose view, which we'll come on to a bit later in this talk. The extended class handles all of the complexities of this view, with the Compose view simply exposing a set content function, which can be used to assign a composable to this view. So with that said, Compose view is essentially a view that we can use to display composables inside of the Android UI toolkit. The great thing is that because this is just another view, we can pretty much use it in a similar way to which we have been using existing Android views inside of our apps. So under the hood, the Compose view utilizes the lifecycle of the parent class so that the composition can be tied to the lifecycle of this class. So for example, this allows for the disposable of composition as required, essentially tearing down the view. So as mentioned, the Compose view is almost like any other Android view that we might be using in our apps. This means that we can add this view to our XML layout like so. Now, because of the nature of this view, as in it's used to display composable UI, there are no custom attributes that can be used to control anything around composables. By adding this to an XML layout, we are essentially adding an empty placeholder which acts as a holder for composables. So instead, a composable needs to be applied programmatically using the setContent function of the Compose view. As we can see, when we call this setContent function, the composable to be composed by the parent class is assigned inside the body, and then that will be composed within our UI. So the setContent function will take the UI that we want to compose, and that UI will be composed inside of the Compose view, and in turn inside of our UI. So we've added a Compose view to our XML layout, and we've got a composable now showing inside of an Android UI Toolkit class. So while working with XML layouts is fairly common in Android apps, it might not always be the case that we want to use a Compose view in that way. In these scenarios, we can add the Compose view programmatically to a layout, just like we would do with any existing Android view class. The behavior and configuration of the Compose view in this scenario will then remain exactly the same as when added via an XML layout. We can use the setContent function to assign a composable to the Compose view, and being able to do this programmatically opens up opportunities in other parts of our code base also. So for example, outside of adding the Compose view to an existing layout, we might want to do something such as return it as the layout view from the onCreateView function of a fragment, essentially using the Compose view as the layout for that fragment. So in your app, it might be the case that you end up using multiple Compose views within the same layout. In these cases, you'll need to assign a unique ID for each one in order for saved instance state to work as expected. This can be achieved by defining the IDs within an ID resource file and then using these IDs to assign an ID to each of the Compose view instances. Doing this will ensure that saved state will work as expected inside of your app. So as we can see from these previous examples, the Compose view empowers us to add composables to existing Android UI Toolkit layouts, both programmatically or using XML. So in a nutshell, this view is essentially going to be used anytime you want to use a composable inside of an existing Android class. While that statement outlines a clear scenario, this can look very different depending on the project and team. So let's try to visualize a few of these scenarios. So maybe you're building a new feature or adding an existing feature using Compose, and the plan to slot that in with the plan to slot that into an existing layout. Maybe your team is learning Compose and you want to tackle smaller and simpler parts of the UI before diving deeper into larger migrations. Maybe you're working with complex UI and want to incrementally migrate an existing layout to Compose. Or maybe a component in your UI is not yet supported by Compose, or there are issues introduced when doing so. So these are just a few scenarios that come to mind, but they all essentially link to the same outcome, which is being able to incrementally migrate to Compose in existing Android layouts. Again, might look different depending on the app, but this incremental approach allows us to move forward with Compose adoption while still delivering value to our users. So now that we've got a better idea of what the Compose view can be used for, there are likely going to be times when we need further support for composables inside of existing Android classes. For this, we have the abstract Compose view class. So for example, while the Compose view allows us to achieve the goal of inserting composables into existing Android layouts, there may also be times where we want to smoothly share custom Android view classes or even composable functions across different parts of our app. Things could also start to get a little complex when we try to work with other parts of Compose, such as state, more complex composables, or views that contain a lot of configurable information. In these cases, it might make more sense for us to extend from the abstract Compose view class ourselves instead of relying on the provided Compose view implementation. For example's sake, let's start with a minimal implementation of the abstract Compose view. At this point, we've extended from the abstract Compose view, overridden the provided content function, and provided a simple text composable. There's one problem though. We don't have any content to provide for that text composable, and we don't currently have any way for external classes to provide a value for that text. In these cases, we're going to need an internal variable reference that can be manipulated and used to control the content of our composable. So here we implement the text property of our view as mutable state. This means that our custom view can still be inflated and placed inside of existing layouts, but this time offering the ability to support some form of internal state. Now in these scenarios, it's best practice to utilize mutable state of objects to ensure that the property is kept thread safe for Compose. So with this in place, this can then be manipulated from our Android classes just like any other view class or binding. The use of this mutable state will ensure that recomposition will reflect any state changes for our custom view. At this point though, what is really the difference from when we were using the Compose view? Couldn't we simply use a Compose view and pass down the state into a contained composable? So what we want to quickly look at here is the composable content that is being used inside of our custom view. We can go one step further here now and split out the composable from our content function into its own composable function, allowing us to reuse this as both a composable function and a custom view class. We will then reuse that composable inside of the original content composable function. Here, we now have a custom view class which can be inflated into existing Android layouts, along with a custom composable which can be used within our composable UI. Being able to add this to a layout either via XML or programmatically means that we can abstract out the context of Compose from our existing classes. Rather than needing to add a Compose view and then assign composables directly into existing Android classes, we can help to keep a clear line between composable UI and the Android UI toolkit inside of those existing classes. So while the previous code is just a simple example, there are likely going to be cases when we are working with more complex custom views that may contain many mutable properties or need to hold some form of internal state. So to begin with, the Compose view does not allow us to add any internal properties for a view, other than what might be provided by any contained views. So while we could configure and maintain any of these properties as state or as part of the Android class that is using the view, we either might not be in a position to support that, and there could also be a lot of duplication for composables that need more customization. And this could easily start to bloat our Android classes. There may also be some cases where it makes more sense for that state to be tied to the view rather than at a global or screen level. So extending from the abstract Compose view allows us to alleviate these concerns by giving us a place to hold these properties and have more control over the composables that we are providing. Alongside this, the abstract composable Compose view also eases the sharing of composables between both Android classes and composable UI. So while we could share a composable function between a compose view and composable UI, the abstract Android view can help to simplify the reuse of composables between the UI toolkit and Compose. So for example, we might have a shiny new feature that adds a new composable to our design system. However, we also need to use that component inside of existing parts of our app. So while the compose view could be used to achieve this, with the details mentioned above, this could get a little complex. We would also need to use our custom composable multiple times inside of multiple compose views, to the point where we need some form of reuse to help smoothen our migration. So to resolve this, we can split out our composable provided by the content function into a separate composable function, as we saw in the last code example, helping to promote reuse inside of our custom view and our composable UI. So if you're still wondering whether you should be using the compose view or the abstract compose view, the approach to implementation likely depends on your app and the current setup. But the general guideline that I'm approaching is the compose view is great for one-off cases where we need to switch out existing views for composables, or we need to house composables for the layout of a parent class, such as a view holder or fragment. And the abstract compose view is great for when we need to promote reuse of composables between composable UI and the UI toolkit. And it also helps to abstract configurable information for a component, helping to keep a clear line between composable UI and the Android UI toolkit in existing classes. So now that we've covered using composables inside of the Android UI toolkit, we're now going to flip things over and move on to how we can use Android view classes inside of composables. So the Android view is a composable function located inside of the Compose UI platform package. This also looks just like any other composable function that we might be utilizing inside of our composable UI. Here we can see 3 different arguments which the composable function requires. If we're already working with Compose, it's likely that we've already utilized the modifier argument when using another composable function. Having this available for this Android view composable allows us to provide modifiers here, just like we would with any other composable. This also allows us to keep any layout, styling, and any other modification properties at a compose level. This is an important thing to keep in mind when mixing the lines of compose with Android views. So maintaining these kind of attributes to your UI will remain smoother if Compose is managing as much of this as possible. If we are mixing this ownership between our composables and Android views, we also start to blur the clarity of responsibilities for developers who are working with this code. So keeping these concepts at the compose level will also help your migration moving forward, as you won't need to double back on your work in future when we eventually come to migrating the rest of the content of these views over to Compose. Outside of the modifier, we have the factory and update arguments. These allow us to provide the requirements for creating and managing the corresponding Android view class. So starting with the factory, this is the block where we will provide the Android view class that we wish to use inside of the Android view composable. This factory block will be called a single time on the UI thread when the Android view is initially composed. Because this ensures that the view will only be instantiated a single time, you can also use this block to perform any other related initializations that only need to happen a single time. And then finally, we have the update block. This is a callback that is triggered once the view has been inflated, meaning that it can be used to set any kind of property data on the view. So whenever any state changes inside of the Android view, the view will be recomposed. However, at this point, only the update block will be called to reflect the state change. The factory will not be called again, meaning that the view reference that was originally created will be retained. So when it comes to utilizing the Android view composable, we mentioned about how there is the potential to start blurring the responsibilities between Compose and other Android classes. So for example, if a developer ends up working in a class that consists mostly of Compose, touching on Android view concepts could add some cognitive overhead, as they would need to be thinking about Compose as well as the Android UI toolkit. In some of my own projects, I've been experimenting with splitting out my Android view usage into separate composable functions, allowing me to essentially abstract these Android UI toolkit references away from my Compose code. And this may not be necessary for Android View composables that do not contain a lot of complexity, but it's a nice way to add a small layer of abstraction should it be needed. We can then access this composable from within our composable UI, and that point of access knows nothing about the fact we are working with a view from the Android UI toolkit. So in most cases, we'll be working with individual composable functions anyway, so this might likely end up being a natural outcome when we're defining composables in this way. Cool, so now that we know how to use existing Android View classes inside of composables, I want to take a quick look into a similar concept, which is embedding XML layouts inside of composables using view binding. So I'm not going to cover what view binding is here or too much of how it works, but if you're using view binding, or if you're not using view binding, one thing you will need to be doing is enable it inside of your project before you can use it with Compose. You'll also need to add a separate dependency to be able to access the view binding features within composables. Once these are in place, we can then start using the Android view binding composable. And as we can see from the code sample, this looks very similar to the Android view composable that we looked at in the previous slides. Once the build tools have generated the binding class for your XML layout, you can use the Android view binding composable, providing the inflated view binding reference to the factory of the composable function. Similar to the Android view, we can then use the modifiers and update block to control the look and feel and the content of our composable. This composable behaves exactly the same as the Android view, with the only difference being the use of the inflated view binding. So this is quite cool because if you've got custom views that solely XML layouts, or maybe you have an XML layout with a custom view class that isn't really doing much other than being a view class. This allows you to essentially remove that maybe Java or Kotlin custom view class and just rely solely on the XML and utilize view binding to have that as a composable inside your project. So this could be a good opportunity to clear out some maybe technical debt or old view code that you don't quite need anymore. Cool. So when working with these different views and composables that help you to achieve compose interoperability, we're likely going to be working with some form of state in our application. And when it comes to compose, this is where things get a bit more interesting. So compose thrives from having a single source of truth, even better when achieved through a unidirectional data flow. This means that your UI is composed from a single state object, meaning that the state of your UI will only ever be reflected by a single source, making your compose state more predictable and testable. However, this definitely comes across as a perfect scenario, and maybe we might have this in an ideal world for sure. But in a lot of scenarios, our apps may never use this kind of approach, or we might be in a situation where we're kind of moving in that direction, but not everywhere that we are using Compose is doing so. Kind of similar to how I guess when a lot of apps were using MVP and then we had the view models and people started moving to MVVM. And I imagine this will be a similar thing where our apps in these kind of transition state of moving from one place to another. So in these situations, we need to work with what we have and take certain approaches to make our state work well with Compose. So there's going to be two scenarios here. The first with Compose being the source of truth for our state. So in these scenarios, the composable holds the source of truth, and we may need to communicate that state back to non-composable code. So in order to share composable state with objects that are not being managed by Compose, the side effect composable can be used, which is invoked on every successful recomposition. So in the example shown on screen, we have some form of state that is kept inside of the composable. So this is represented by the isEnabled flag. I've omitted how this is calculated, but this just represents some form of state in the form of a Boolean. So our composable takes a back dispatcher into its function. And what this composable needs to do is update this listener based on this enable state. Here, a side effect is being used to update this value. So whenever a successful recomposition occurs for this composable, the external state that is referencing that flag will be kept in sync. So this is necessary when we're working with composable and we're communicating back to non-composable code. So on the flip side, we might also need to work with the state being inside of the view system, something that we are likely currently utilizing in our Android projects. So for example, a lot of Android views hold their own state, which we access when needing such data, such as the text from a text view. So in these cases, we can keep the composable state inside of the view system, treating it just like standard view state that we might see elsewhere in our apps. In this example, we have a custom view which contains a text view, along with a text field composable. The text view is used to show the content that is entered into the text field, and because both of these have state, we need this represented within the view and for both of them to be kept in sync. So here we use, again, a mutable state of object for the composable state to ensure that it is thread safe. And this then allows us to keep this view state inside of our Android class and not have to keep it outside of our composable. So this gives us the result of reflecting composable state inside of the Android UI toolkit. So regardless of how you're working with state, there are several state-related functionalities that are available for different streams of data. So whether your app is currently utilizing live data, flow, or observables, these can be utilized as composable state using the corresponding functions from the framework. So this means that recomposition can be triggered whenever any of these data streams are changed. So if you're using live data and you set or post a new value to that live data stream, your composable state can be recomposed. So if you're interested in using these, check out the corresponding Android X Compose runtime packages for more information on what is available and how you can use them. So during any of this migration, be it working with state or UI components, there's likely going to be some places where you'll need to call the Android framework from within Compose. There's a couple of talking points here that I wanted to mention before we start to wrap up the talk. So the first is context within Compose. As we might be aware, we access the context in a lot of places for our Android projects, and there are likely going to be points in our Compose projects where we need to do the same too. So we can access the context using what are known as composition locals. Composition local is used to propagate values for different Android framework types inside of Jetpack Compose. And this includes things such as the view, configuration, and context. These are prefixed with local, so that when you're working in your IDE, autocomplete will help you find them. But the context is accessed using the local context. We can then use this for anything that might require context. So for example, if we want to create an instance of an Android view class to use within our composable UI, we can access the local context and use its current value to retrieve the context and use that as we wish. So before you start using local context, it's definitely worth checking out what functions are already available inside of Compose, such as these handy utility functions, string resource, color resource, and so on. So under the hood, these actually use the local context under the hood to fetch the application resources and then fetch the string or color. So to save yourself duplicating what might already be provided by the framework, be sure to check out what is offered in terms of resources and so on. So now that we know how to add Android views to our composable UIs, one thing we might need to be aware of is how to adhere to the lifecycle of these additions. So for example, we might be running some process or utilizing some class that needs to be stopped or cancelled when our activity or fragment is destroyed. In these cases, we can utilize what are known as side effects in Compose, which we touched on briefly on a previous slide. So there are many side effects available in Compose. By many, I mean, I think about 10 or 12. But in terms of interrupt with Android classes, the disposable effect is an important one. So using disposable effects, we can work with composables that require some form of disposal. So the disposable effect actually takes a key which is used to determine when this effect should be run. So if we have some class or reference that might be changing, we can provide that as might not be changing, we can provide that as the key so that our disposable effect is run whenever that changes. So if it's not going to change, we can simply pass some constant value to run the effect a single time. But we have an example on the screen here, which of a view which takes a listener. However, when this composable is decomposed, I want to be sure that we avoid any possible leaks. So for this, I provide an Android view reference as the key. So as my view never changes, we don't need to worry about this being relaunched, followed by utilizing the onDispose callback of the disposable effect to tear down my listener. So I am now safe from having leaks from my listener, and this listener will be stopped, and then we don't have to worry about any listeners being triggered when our view's been teared down. So this is a simple example. So in some cases, we might need to integrate lifecycle observers to adhere to specific events, but in these cases, we would still be able to utilize the disposable effect to manage our composable and its own lifecycle. And again, this is only one example, and I would recommend checking out the developer documentation to see what other side effects are available. If you're interested in the lifecycle observers and adhering to disposables that way, I think it's the crane, maybe the crane in the official Compose sample repository by Google. I think the crane project uses a Google Map Android view, which has lifecycle checks to dispose of the view correctly inside of Compose. So that was a good example to check out if you're looking to find out for more information on this. So during migration, whether you're working with state or trying to interact with the Android framework, there are likely going to be times when things get tricky or don't quite feel right. And that's okay. So rather than trying to force or wedge things in place, we can follow the guideline of flowing data down and passing events up. So to take a simple example, here we need to trigger the launching of an activity when a composable triggers some event. We trigger this activity launching from within our Android UI toolkit code, but this event is actually triggered from a callback within our composable function. So what happens here is the button inside of our composable is clicked, and then the click listener, which is passed into our composable, is triggered, which then in turn launches our activity. So as mentioned, this is a simple example, but it does demonstrate how we can approach some of these things and simplify them. So we don't have to worry about our compose using the context or anything else, because we're keeping that stuff inside of our UI, the Android UI toolkit. And the same can be done with state management and other framework interactions. So if in doubt, follow this approach of passing data into composables and flowing events up into the parent. So a lot of composables obtain their theming from theme attributes taken from the theme which you apply in Compose, or from defaults if a theme is not set. So it's very likely that you have some form of theming in your application. The good news is that if you're using the material or app compat theme, there are supporting libraries that allow you to utilize this theming for your composables without needing to recreate and define a new Compose theme. So in Compose, we might have a theme defined like so. This wraps our composable content and applies a theme to it. When doing this, we need to provide any of the attributes that we want to be using our theme, such as colors, shapes, and typography values. The great thing is that using the MDC theme adapter, the composable function will automatically read the theme from the host context and provide them to the material theme. This means that our material theme can be automatically applied to Compose when using this function. To use the MDC theme adapter, you'll need to add the following dependency. If you're using an app compat theme, check out the official documentation for notes on a similar library for that use case. So it is possible to customize the values that are being used by the MDC theme adapter, which can be achieved by using the create MDC theme function. And this will generate the theme colors, typography, and shapes, which you can then use to pass the theme onto the material theme. You can use to pass these into the material theme function to render your Compose theme as normal. Cool. So that's it from my side. Before we wrap up, if you're looking to learn more about Jetpack Compose, there's obviously the official pathways and Google documentation. I do also run a website called compose.academy that has snippets, guides, and blog posts, which are focused on Jetpack Compose. And if you're looking to learn more, please check that out. And we're also currently working on our practical Jetpack Compose project, which will be released later this year, which you can sign up for more information if that is something that you would be interested in. But yeah, that's it from me. Thanks for watching, and I hope that was interesting.
Thank you so much, Joe. That indeed was interesting. So, everyone, if you have any questions that you want to ask Joe, please put it in the live chat, and we'll have the Q&A session at the end of all the 3 talks. Okay, I will now have the next speaker on stage. Hello, John. John is at Kotlin GDE and has been developing Android applications since 2010. Oh my God. Android was started in 2010, right, John?
Shortly before that, I think a year or two before that, I think it was, I guess it was picking up momentum around that time.
My God, that's a long journey. Wonderful. And then before that, you were on server-side Java applications and then desktop clients even earlier than that. So I could definitely consider you a hardcore geeky person.
Yeah, pretty guilty.
Okay, I am excited about the talk today. And because, kind of going to show it off too. I work for the company. So pretty excited what you have to share today. So I leave it to you, John.
Thanks. I'll share my screen now. Okay, just the usual confirmation that you can see my screen okay. I assume that's a yes. So hi folks, my name is, as introduced earlier, is John O'Reilly, or shown here is John O'Reilly. I'm a software engineer here in Galway in the west of Ireland, working for a company called Neat, a Norwegian company. And when I talk today, it's a pretty broad topic and not, within the sort of half an hour we have, I guess we're not going to go particularly deep in any of these topics, but what I'm hoping what you'll get out of this, if nothing else, at least, is sort of get a flavor of what these technologies are that we're going to talk about, the capabilities that they provide, and see sort of an example, at least, of how they can be used in a solution like this. And the talk is going to be based on a GitHub repository that I have. And I have a number of GitHub repositories that are based on different Kotlin multi-platform scenarios or use cases. And you're obviously very welcome. I encourage people to try those out later on. Maybe if this is something that interests you, if you're interested in Kotlin multi-platform or Realm or whatever the things we show today, then definitely try those out and give you an opportunity, hopefully, to dig a bit deeper. So, as I said, we're going to start with sort of giving a couple of slides, really just to give some initial context. It's primarily a live coding session where we sort of build out a sort of a basic application that uses these technologies. But I'm going to start with just giving a quick overview, just a couple of slides, just to level set. I'm not too sure how much people here are familiar with some of these things, but just Kotlin multi-platform, I suppose, at a high level is just the ability to run Kotlin code natively. And this is important that it's compiled. There's a number of different Kotlin compilers that will compile the code on each platform to run natively on each of them. It sort of differs significantly from other approaches, other sort of what you might call cross-platform approaches like React Native or Flutter, in that it's sort of more accommodates what's called optional code sharing, and this sort of ability to incrementally adopt the shared code. So you can sort of use it a little or as much as you want and sort of gradually build it up from there. And typically the focus is on and again, this is a differentiator, it's focused on sharing non-UI code. And having said that, I mean, when you build you're ideally, I would say, as we've seen an example, that when you build your shared code, you're primarily hoping to build code that will run on each of the platforms. But having said that, the ecosystem does support the capability then to access platform capabilities if needed. And we'll see some examples of that too, or we'll see an example of that at least. This is sort of a quote from Kevin Galligan. I'm just leaving it in here. I suppose just, I guess if you are interested in Kotlin multi-platform, I definitely encourage you to follow Kevin and Touch Lab, the sort of pioneers in this space. Cover some of the points, I guess, from the earlier slide, and plus one at the end that he added in recently, which is this and JetBrains, was really sort of emphasized that this is something, I'm sure everyone knows who JetBrains are, the sort of the creators of the Kotlin language and the IntelliJ IDE, for example. But they're fully behind. They've over time, over the last year or so, they've been sort of steadily ramping up their commitments to Kotlin multi-platform, and we're seeing that in terms of the output, in terms of things like Kotlin multi-platform mobile, which is, I guess, has been a sort of a rebranding to some extent by JetBrains, really focusing in on what we're going to talk about a little bit today, which is sharing code on mobile, iOS and Android. And so along with sort of, updated documentation and guidance, then there's a very nice Android Studio plugin then, which you can use. Prior to that being available, it was always sort of hit and miss a little bit. People starting off with Kotlin multi-platform in terms of how to get up and running, get your build configuration correct, and so forth. Now there's a nice plugin where you can create a new iOS and Android application and run and debug that application from within Android Studio. So Realm, in a mobile application, typically, we're going to persist data locally. We're going to cache the data. We might retrieve the data, as we are going to do today, from some remote endpoint, and we want to store it locally. And there's a number of different approaches to doing that. So Realm, a relatively new addition, to the Kotlin multi-platform library ecosystem, is a library that provides that support. It's sort of seen as an alternative to using the likes of Core Data and SQLite. And another differentiator is, I guess, this kind of focus on this object-oriented data model. And sort of just to jump into an example straight away, and again, we'll see this in the code. The project we're going to talk about today is a sample I have, which is Fantasy Premier League. It's just an application to see sort of Premier League players, how many points they have, and so forth. And this would be an example of a sort of schema, you could call it, that we have this object schema. We have a team DB and a player DB class. The player has a reference to a team, and again, you see that sort of object-oriented nature, so the attributes there and the relationships that you have between those. And then on the right, then we see, having a list of teams or list of players. This is how we might iterate through those, and using the sort of Realm terminology, we copy to Realm. We create a team DB class from the attributes that we have, and we store that in the Realm database. Declarative UI. I did, by the way, this is going to be somewhat of a whirlwind tour of these technologies, by the way. So, if people have questions, definitely afterwards reach out to me. I have my Twitter handle on the slides, as well as Joe mentioned for his as well. So definitely encourage people, if they do want to sort of know about any of these things in more detail. So Joe did cover some of the topics around sort of Jetpack Compose, and hope folks have probably seen the announcement yesterday. I'm sure you have, of the stable release of Jetpack Compose. I just have this, I suppose, just at a very high level. If you haven't come across Compose or Swift UI or Declarative UI in general, then just very briefly, I mean, these are seen as sort of, when people use the term declare, so you declare or you describe your UI in terms of what it should look like in a particular state. There's just what versus how. Traditional imperative approaches are more step-by-step how to create a UI. The likes of Compose and Swift UI, you describe what your UI should look like in a particular state, and state is very important, as sort of Joe touched on in the earlier talk. Any changes in state then will be reflected automatically in UI. What's described in the Compose world as sort of recomposition. And we see the same concepts, by the way, very importantly, in Swift UI as well. Very brief history. Compose was announced at Google I/O in 2019, went stable yesterday, as mentioned, available in the stable Android Studio Arctic Fox, which also went stable yesterday. Swift UI was actually announced a couple of weeks after Google Jetpack Compose at WWDC in 2019, and it was at a more advanced stage. It was available in the Xcode beta that evening, and that sort of got me started down this path. I sort of downloaded Xcode and started trying it out, and started using it with Kotlin multi-platform, and it allows sort of the building out of user interfaces across all Apple platforms, which is interesting. This is the example we want to talk about today, which is building a basic Android and iOS application that shows a list of players, some data about them, the team they're in, and the number of points they have. And we'll see this in the code in a moment, but just at a high level, just again, if people haven't seen Compose, just give you a flavor of what it looks like. In Jetpack Compose, we typically, or we define our UI in terms of what look like standard Kotlin functions that are sort of annotated with composable. And these composable functions are typically, like shown here, we pass a particular piece of state, a player in this case, and we describe what our UI should look like in that state. So we're showing for a player some information about their image, some data about what team they're, the name, and applying various styles and so forth. If we look at Swift UI then for the same, and what we're showing here, by the way, just to go back here, we're showing what would represent a row in this list. Very common pattern, obviously, in mobile application development is where you have a list of data and you want to show something, a row representing some particular piece of data that's in that list. So in this example here, we want to show a player. This is, as I said, what we have for Compose, and then for Swift UI, we do something very similar. Instead of a composable function, we have a Swift struct. We're passing player in as we did in Compose. And we'll see in the context of Kotlin multi-platform, this player is coming from our shared code. It's the same class that we're dealing with, which importantly. Instead of row and column, we're using HStack, VStack. Instead of image, we're using image view. We have a text element. The way we apply modifiers, styles is a little bit different, but hopefully, what you'll get out of this, even just from looking at this example here, is just how fundamentally similar these are to each other. This is the repo that today's talk is going to be based on. The repo, not to too large an extent, but the code, the project that's in GitHub builds out, a slightly more complex UI, deals with fixtures and more details about the players and fixtures. We're going to just focus in just to sort of illustrate the key parts. on the sort of the list of players. But as I mentioned at the start, you're very welcome to pull this down and various other projects that are on GitHub that demonstrate various Kotlin multi-platform samples. Okay, so how are we doing for time? Okay, so I'm going to jump in. I'm going to hopefully we're going to go, like I said, through this relatively quickly. Don't worry if the code we pull in doesn't make sense immediately. I'll try and come back and forth and give some context. I'm going to avoid try to avoid you watching me mistype a lot of code. So I'm going to make active use of Android Studio live templates, and we'll see in Xcode code snippets to sort of pull in blocks of code. I'll explain obviously what I'm doing when I do that, and using them as often as a sort of a segue to add some additional sort of commentary to what we're doing. So this is Android Studio, and when I mentioned about KMM, one of the I guess the artifacts that were created as part of that sort of effort is this new Kotlin multi-platform plugin. And what this allows you to do is allows you to create a new project in Android Studio with an iOS and an Android app. You specify, the name of your Android app, the name of your iOS app, and the name of your shared module. And this is the project we're going to start with today is one that I guess you could say I've already gone through this process just to save you sort of going to see all the sort of initial steps involved. But it's fundamentally based on taking this approach. And the other thing worth noting here, and something we won't go into a tremendous amount of detail in, is that there's the mechanism described, or there's an option here to describe how you want to link up your iOS framework. So at its core, I mean, it's a good point to mention. What we're dealing with here is we have this shared code. We want to consume it on Android and iOS. On Android, it's almost a no-ops coming through as a jar file. What we will get out of the sort of the Kotlin multi-platform capability and associated plugin is that the shared code on iOS will get an iOS framework will get created. And in Xcode, then we will pull that framework in and we'll start using that. There's a number of approaches to how you sort of set up the plumbing to support that. The one here, the default one now is what's called CocoaPods, and this is what this project that we're dealing with is based on. So just to say, without going into too much detail, just supposed to mention that this is sort of a way that we can set up the plumbing. And fundamentally what we want to do is that when we go into Xcode and we hit run, we want to be able to make sure that when it will go out and it will build that shared module, the shared code module using Gradle, create a framework and make that framework available in iOS. So this is the sort of, I guess, I think somebody also once described these kind of talks, these live coding talks as sort of a cookery show. So we have some stuff pre-prepared and some stuff we're going to make fresh. So a pre-prepared project to some extent here, and so an empty shell of a project. We have our app module, which is our Android, which we're going to see. Obviously, we'll write some compose code at some point for that. We have a common module, which is our shared Kotlin multi-platform code, and this is where we're going to put our code to go to a remote endpoint, retrieve the data, and then store that locally using Realm. And then we have an iOS application, which we'll switch over to in a little while. So let's start off. We're not going to focus too much on the sort of remote API request. So we're using a library called Ktor. And if you're writing Kotlin multi-platform code, and if you're communicating to a remote endpoint, you're more than likely using Ktor. And Ktor is just a very nice library where we can create a sort of HTTP client. We can make, given a particular URL, we can call a get on that, and it will, in this particular instance, using something called the Kotlin X serialization library, or if you're doing Android development, you might be familiar with something like JSON, but something very similar. Kotlin X serialization is also sort of a multi-platform capable library. We can automatically pull back the JSON and sort of deserialize it into a set of objects, data transfer objects. And again, we're not going to focus too much on that. I have a number of other samples I have also deal with using Ktor, but just at a very high level, we're going to start creating this class that will go to this endpoint and retrieve this data. Our main focus is going to be in this repository class, and here we're going to use that API class that we just added, and we're going to retrieve the data and store it in the local database. And then ultimately, what we're going to do is, and this is obviously a very standard pattern in mobile applications. We'll drive our UI from that. We'll observe the changes any changes that are made to the database, and we'll drive our UI, our Compose UI, and our Swift UI code from that. So we'll start adding in those Realm objects that we saw in the slides. So nothing too dramatic here, I suppose, in the sense we're using Realm objects, we're creating these classes. We have attributes like names, points, cost, and so forth. And you can see what's interesting here is, again, as mentioned in the slides, we have a player that is linked to a team. Now, if we start building out our repository, sort of a few things to note here. We are using Coin. So let me just jump into, I'm not going into too much detail. If you haven't come across Coin before, maybe you're familiar with Dagger. Coin is a dependency injection framework. Again, what's interesting about it is that it's Kotlin multi-platform ready. We use Coin to sort of declare a number of dependencies. We have our Fantasy Premier League repository, our API class that we created a moment ago. We have some sort of configuration of the API class and configuration of how the JSON is sort of serialized, deserialized. And in the context of Realm, we've defined this Realm configuration, which is configured with that player DB and team DB classes that we added a moment ago. And then our overall Realm objects that we're going to make use of when we're making queries, when we're storing the database or observing changes to the database. Okay, so our main thing we want to start adding in, and this is probably the biggest block of code I'm going to pull in. So bear with me in terms of just let me explain. There's a number of sort of relatively basic things going on here, I guess. We're using that Realm object that we created, that are at least that we injected into our code here. We are doing a sort of a basic form of I guess, a number of different strategies, of course, to how you synchronize data from your backend to the database and so forth. We're taking a very basic approach here where at startup, we're going to read this data from the endpoint using that sort of API endpoint class that we added a moment ago. And we're going to create a Realm write transaction to delete all the existing data in the database. And then we're just going to iterate through the data that we got back from the endpoint and use this copy to Realm that, again, you saw an example of hopefully in the slides as well. And the other thing to note here is that when we copy in the players, then we create a link then to the team. So again, that's our object-oriented approach that we mentioned. So having this fetch and store data, we want to call this from somewhere. So let's, again, in the context of this, as I said, a fairly basic example here, every time the application starts up in a block of a repository, we're going to go off and fetch the data and store in the database. Again, in a sort of real, in a more robust application, obviously you would use potentially different strategies to how you would do that. And the last part of this puzzle here is we want to actually observe the data then. And this is simply, we're using the Realm object, we're using its observe method and its collect extension function. So this is the other interesting thing I'm supposed to point out is that this Realm library is sort of Kotlin ready, and it's Kotlin concurrency ready in the sense of using, when we use realm.write as a suspend function, and when we're observing changes to the database, we're using collect. We're collecting that as a flow from the database. So again, the flow will be, somehow something will retrieve that data. Maybe in a real application, you'll use something like WebSockets or your polling. That data will get stored in the database, and then we'll have some kind of code like this that observes changes to the database and notifies the UI. And when we say notify the UI in this context, we're making use of a state flow here that we're updating. And we'll see when we go into the Compose code how we can kind of observe that directly from Compose. And we'll see a little bit. But what we're going to do a little bit differently for iOS. And add the function which we're going to call from iOS. And this is a sort of big topic in its own right, I guess, in terms of how do we map from sort of Swift code to Kotlin code. Kotlin 1.4 added the capability to call suspend functions directly from your Swift sort of Objective-C code. That comes with some caveats in terms of the scope you use and lifecycle and cancellation and so forth. For this basic example here, we're going to use, which is a common enough pattern, is where we'll pass in a kind of completion handler, a closure in from our iOS code into our Kotlin code. And then we'll collect from that player list the state flow that is, the state flow that's updated. If we go back up here a moment, the state flow value that's updated every time the database changes. So that then we can call back to the completion handler to our iOS code, and it can update its UI. Okay, so let's write some Compose code. You've seen some examples in Joe's presentation, but I'm going to work my way up through the hierarchy here. We're going to start at the bottom, with the player view. And this, again, is something we showed in slides before. Compose obviously is sort of driven or is based on the idea of these sort of composable functions, these reusable functions which are as stateless as possible, as free of side effects. And the idea of something like this where we can pass in a player and it just renders that player. That function that we've no sort of control over, or we've no dependency of how that gets called or when it gets called or how often. So you'll see that theme as you dig deeper into Compose, and I think as we will collectively as a sort of, in the Android development ecosystem, you'll see some of those patterns obviously become more established in terms of how we manage those and how we manage state. And state management, as sort of Joe alluded to in the earlier talk, is very important in the world of Compose. So let's work our way a little bit up the hierarchy. We have we now have a list of data. And this is a good point, I suppose, to draw the comparison. If you have been doing Android development, I'm sure you're familiar with using recycler views and view holders and view adapters and layout files. this is sort of the sum total of what you have to do in Compose. This is our recycler view, and effectively we have a list. We're passing in the case of the player list view, we're passing in the list of players. We have a lazy column here. We're iterating on the players, and then we're invoking this player view with each of those. So let's move a little bit further up. We're going to add something which represents our sort of overall screen as a whole. For now, it simply invokes the player list view, which we added just a moment ago. We'll modify that a little bit in a moment. But what I want to point out here, I suppose, is that we're starting to use, we had that player list, and I'll go back to that again in our repository, which is this state flow representing, the state of the list of players exposed in the repository. And in our activity then, in our Compose code then, we can use Compose's collect as state extension function, which will map that to sort of Compose's concept of state, which is a little bit different maybe from what we have in other parts of our application. And having done that, we've automatically sort of, I guess, what would you call it, enrolled, I suppose, in the sort of Compose mechanism, such that any changes to that state automatically cause the UI to be updated. Whenever that player list is updated, ultimately through that database, obviously being updated, then Compose understands that. It can see what other composables reference to that player list, for example, and knows kind of in an optimized way how to sort of relay out our UI to reflect the changes. And if we go finally up to our activity, typically in a Compose world, albeit maybe, if you're, again, sort of touching on the earlier talk, you may have scenarios, obviously, where you're mixing and matching between your existing application. But in sort of a new Compose application, you'll probably typically only have a single activity like this. And instead of having sort of set content with your XML layout file like we would typically have, our set content is an extension function which allows us within that then to sort of apply that theme that Joe mentioned as well, and to just invoke the main layout. And just the last thing to mention here is that, again, we're using Coin to inject this repository. And again, this is a very relatively basic example. In your own application, and certainly some of the other samples I have, we would use something like an Android view model to represent the state and any sort of mappings and transformations that we're doing, and observe changes from that. But in this case here, we're dealing with the repository directly, just sort of, as I said, in the context of sort of illustrating the key moving parts as sort of as simply as possible. So I'm going to run that, and while that's running, again to sort of, I guess, recap a little bit. What we've done so far is we have an application here. It's got a number of different modules. It's got a module for the app. It's got a module for the shared code. That shared code, when we build on Android like this, is just going to be a jar file that's consumed. The surface area exposed from that shared code is a repository class, and it's the same surface area that is exposed to the iOS client as well. Again, in another example, you may have something like a clean architecture where you have a use case interactor, use case or interactor layer, and that can also go in your shared code as well. Okay, so this is our not relatively big, but very basic UI that we have from that list. Let's maybe make a few changes to that. Instead of just invoking the player list directly here, we can use scaffold. And scaffold is Compose's sort of, I guess, representation of a screen. In this case here, we're using a top app bar. Again, the example in the repository also has a bottom navigation where we can navigate between different screens. And if we run that, okay, we get a top app bar now. Our UI is looking a little bit better. And lastly, maybe we'll make some changes to the row here, and we'll add in a it's worked correctly for me. We'll add something representing the image, and this is a composable function again, and sort of capability to render an image from a URL. This is the URL coming back from the data that we got. If we run this. Okay, and our UI is looking a little bit nicer. So let's switch over to iOS and try to do something similar. So I have an Xcode project here. You can see I've already imported this Fantasy Premier League kit, and this is sort of in our, if we just briefly go back over to our sort of, I didn't delve too deeply into the sort of the build, the Gradle file. This is probably one of the more complex aspects of Kotlin multi-platform, and this is why you're definitely recommending, it's definitely recommended that you use a template or sample to start off with, getting the the build Gradle for your shared code can be a little bit problematic starting off. But just to point out, I suppose that we have in here, we're using the Kotlin multi-platform plugin. We're defining a couple of targets like Android and iOS, obviously. And we have some CocoaPods configuration. And we can see in this CocoaPods configuration that we've configured that the framework that will be, the iOS framework that will be generated is called Fantasy Premier League Kit. Ultimately, what that means then is that's something that we can import into our iOS code, into our Swift code, and start using. So in a similar way to our live templates we're using on Android Studio, I'm using some code snippets here on in Xcode. And again, if you think of that list that we're trying to create, we have something representing our player view. Again, so you probably saw the example from the slide as well. Very similar idea. We're passing in a player. And again, note this player is coming from our shared code. We're showing an image of that. Instead of using, as I said before, row and column, we're using HStack and VStack and so forth. But again, very similar concepts. In this case here, we're just going to have something at the high level representing our overall screen. And this is where things are a little bit different. I mean, obviously the concept of a struct versus a Kotlin function is one difference, but the way we do navigation is a little bit obviously different in Swift UI to Jetpack Compose. We're using this navigation bar title, set up our title as opposed to sort of the likes of the scaffold that we were using in Compose. But the way we render the list is very similar. We have a list object here. We iterate through the list, the player list, and we invoke this player view for each element in the list. And the other thing to note is that we're using this Fantasy Premier League repository class, and that's the class coming from our shared code. So this is very important. This repository class and the player, the sort of the data model entities that we're using here are the same classes that were used on our Android client and that we're using directly on iOS here. And if we run this, and again, while this is running, I suppose just to comment on a couple of things. At this point here, what it's going to do is it's going to, based on that plumbing that I mentioned, I kind of alluded to, is basically sort of some run scripts that are configured in Xcode to automatically invoke Gradle to build the appropriate framework for the appropriate target. That's going to take a little while initially. The build time actually here has sped up significantly over different releases, and this kind of talks to that earlier point about JetBrains continuing to invest in Kotlin multi-platform and continue to sort of make this process faster. But having done that, any subsequent runs, as an iOS developer here, who's sort of focused on my UI, focusing on creating compelling user experience, has this shared code from the Kotlin multi-platform, isn't making maybe many changes to this stage, their workflow is going to be pretty much unchanged. The time to build would be very minimal at this stage. Once, as with sort of Gradle in general, it hopefully recognizes that no changes have been made, comes back pretty quickly, and then invokes our builds the rest of the Swift code and builds the rest of the Swift UI code. And this is what our UI looks like. And again, very similar to obviously what we had on Android, based on the same, hopefully, as I said, it's a bit of a, more than a bit of, I guess, it is very much a whirlwind tour of these technologies. But as I said, I'm hopeful from seeing these at least, it gives you sort of a flavor, again, using that word flavor of what these technologies are, the capabilities they provide, how they can be used together, how a solution like this, how relatively easy it is these days to create a solution like this out of these sort of moving parts. And thank you very much. Not sure how I did with time. I think Fahad, you're muted.
Fahad, you are muted.
Sorry, I did it again. Thanks, John. That was great. Hopefully you'll stick around at the end for question and answers. That'd be good. So next up we have, if we could just get them on screen, Niharika and Aurora and Himanshu Singh. We could just get them in the thing.
Hey.
Great. Hi, how you doing?
All good. How about you?
Yeah, good, thank you. Just a quick introduction. Niharika is a software engineer who works at 1MG. She's one of the core contributors for the Government of India's contact tracing app to fight against COVID-19. She's also an active blogger, open source contributor, and public speaker, and has been recognized by India Mentor and Corporate Insight for giving back to the community. Apart from coding, she loves to mentor people and help them to learn and grow. And Himanshu is a Google developer expert, a GDE in Android, and has worked on multiple domains like healthcare, rental, and gaming platforms. His primary focus is on building robust architecture and making apps scalable. Apart from the Android domain, he's an active open source contributor as well, and a backend developer. Also, he loves Kotlin. Do we have a video for Niharika?
I think she would not be on the video today.
Okay, no worries.
I do have a bad internet, but I'll try to make it up with a good talk.
Of course, yeah. I will let you guys take it away. If you just change.
Let me share my screen.
Go ahead, Niharika.
Okay, so is my screen visible? Himanshu?
It's loading as of yet? Oh, yes, it is.
Okay.
Awesome.
So
all the best.
Yeah. Yeah, you can start now.
Okay, so the topic for this day is FOMO. And when we talk about FOMO, right, it has been more of if we miss out on something or if we are seeing something as a hype which is happening around. So in our sense, if we have to talk about anything which is coming up, right, when I am building something, for example, I sometimes tend to miss out what other people's do, or sometimes I miss out what new releases are coming up. So this talk is all about that.
Okay, so but we won't be talking about like FOMO in general. Otherwise, this talk would never end. Everyone has their own FOMO in every field, whether it's personal or professional. But we being more into Android, so and I think with Android as new things are coming up every day, every month, every year. So and we can't cope up with everything. So we always have this fear of missing out, and with Android it's more. So we'll be talking about this today. So before we share our learnings and experiences with you, Himanshu, would you like to introduce?
Get that. Could you try again?
Himanshu, would you like to introduce?
I'll go first. So as Fawad said, I'm a Google developer expert for Android, but also with that, I recently joined a Berlin-based startup called Clue. So I worked there as an Android engineer.
Okay, so Fahad has already told many things about us. So I'm also a Google developer expert for Android and currently working as a senior software engineer at 1MG. So as we just had a Google I/O, so let me just talk about the latest things which we had. So before that, Himanshu, would you like to talk about your experience? Anything you expected or anything excited you had?
Sure thing. So if I have to give it my experience which I had with Google I/O, my traditional thing was I was expecting something on the hardware side. So I was actually planning to get a new phone, and I was expecting Pixel 2 be launched or a hint of it, but I was actually disappointed by that.
Okay. Okay, so let me share my experience, like what I learned or what I got from all.
How about you?
All this. Yeah. So we had this Lambda. I don't know if many people know about this. Like as Google's main aim is into now into ML and AI, so it is making the human voice and the conversation skills for all the gadgets and machines we have. And then, of course, there can't be any Google I/O without any new Android version getting launched. So we have now Android 12. There are many changes good for users, but maybe not for developers. Then we have Smart Canvas, which is like Google is making their workspaces more smarter. Google Docs and Slides are now having very good experience in terms of like they are now getting more smarter every day, like having more calculations getting done on their own. And this list would never end because there are many things which were discussed in Google I/O, and I think we can't discuss everything. But yes, this is all about the Google I/O. We didn't talk about the Android part, which we really love. There are many things in Android. So anything, Himanshu, which you find in Android which was exciting for you?
Traditionally, the thing which I liked in Android is the new material design system, Material U, which fascinated me.
Yeah.
That was one of the aesthetics which I liked about Android. What about you? What did you like about the Android ecosystem this year?
So just to summarize this, as you already told about the material view, which is like you can now customize your color palette, themes, and it will be just like for the tech industry, it will be like a major transformation in material, the design system we had. Then we had many APIs for animations. We have got many blur APIs, render effect APIs, which has made now again with the blurring thing. We had many difficulties before that, but now we have got many APIs around it. Then, if I have to talk about the security and privacy, I think again, as I talked about, like for users, it has become much more secure. But for developers, there are many changes to be done. Like now, you can give approximate location. If you don't want to give the exact location, you can also you can see like all the applications which are using all permissions in your like in your device, which permissions are getting used by in any application in your phone. Then we have so widgets we already had a time back. I think most of the applications are not like having much widgets, are not having many widgets for them, but now widgets are again in picture, and there are many drastic changes happening in widgets. Then, as we talked about the blur APIs, the permission APIs, and again there are many APIs which are converted from alpha to beta, then beta to production. So till the time I figure out like what will be the process to migrate, I'll hand over this to Himanshu. So and he can talk about the dev ecosystem.
Cool. All the best with your figuring out of the whole migration process. I hope it goes smooth. So, okay, it was a basic overview what Google I/O had for us, right, in Android ecosystem. But if I have to broaden my area or the range, if I have to put it that way, consider, okay, let's start with as 2021 as an ecosystem itself. 2021, what was the best thing? Like what was we doing? Like the whole ecosystem changed Jetpack Compose, and with this, if you remember Jetpack Compose, we had, for example, the latest version, the stable version coming up today, right? Then we have data stores, which is traditionally the async version of shared preferences, which we have to go through. Then we have a new dependency injection, Dagger Hill, built on top of Dagger 2, but it's still there, right? It's an amazing thing. We have Coin. Then one of the most talked popular features are coroutines and as well as flow. So coroutines and flow has been there for ages, right? It feels like it at least, but it is there for us, if I have to put it that way. Then we have a navigation component, and if we talk about it, right, people have started using minimal number of activities and number of fragments, or single activities and fragments, right? Then we have, if I have to put it in this way, we have n number of things also coming out. There was an emoji SDK library. It was something else, something that. And just a second, what I wanted to tell you more is, this is just not it. We are actually just getting started. So why I'm saying you this, the list can go on and on. We have a very small limited time, which we have to figure out. So we just got started. But the bigger question is what we need to do to understand these number of things. Or if I have to put it another way, how we need to do this. Because if I have to put it in a broader picture, your app was not written yesterday. Your app was written n number of days back, couple of years back. and we still need to support the users, right? So what I would say is these two are not the important questions. The bigger question is, why do we need it? So maybe Niharika can explain if she has figured out her migration strategy.
Okay. So one thing I have learned from my experience, I think most of us can relate with this. Till the time we don't need something, I don't, and you don't feel the necessity, I think there's no need to get into depth of any technology or framework, because anytime eventually if you have to use it, you will be knowing it in depth. But otherwise, let's say there are like, again, as Compose was there, then we have the Dagger Hill, then Coin. So till the time you don't feel the need, it's not necessary to use it. And it's like the things will be like every time there will be many libraries, latest trends coming up. Don't go with that hype, and just check what your application actually needs. Maybe if you need the testing part, you can go for writing unit tests. The TDD approach is always good to follow, but again, you have to cope up with other things like the business goals and needs. And if you are with on your startup idea and you have to just release in lesser time, so you may be just going with the features only, and then improvising with the architectures, or maybe the dependency injection framework you are incorporating, or maybe writing test cases. So you just need to check the necessity at that particular moment. Then again, as I talked about the startup idea, maybe you have got just lesser time, or maybe there's some feature which needs to be rolled out at just in few days, and you are just doing over engineering. And when it goes live in production, at that time maybe it's not worth it. So you have to deal with all these things and balance between the maintainability and performance. So there should always be a balance between performance and maintainability. Maintainability comes when you have already become a stable product or stable idea, and then you go for the maintainability part. But maybe the performance aspect you can take over and make the user flow and UX smooth for the users. And again, as with all these things, anything you are working on, check out if is it really worth it to use or not. There are many applications which are not till now not using architectures, but still they are working perfectly fine. So this is just one basic example, but you have to find your own ways and reasons for using anything and the time at which you are using that. So once me and Himanshu were discussing about this, and I really like this from our discussion. Like anytime you are going for, he's a filmy guy, so he loves to have these kind of quotes. So anytime you are building anything, go for the business needs, then see what your user wants, and then go for the performance part, like what your application needs. And then after that, if you have maybe people or the time left, maybe you have some platform team available with you. Parallelly, you can work on the maintainability. Himanshu, do you want to add something to it?
No, just on the filmy part. It's more like that. I like Bollywood movies in a sort of way. So this is not my code. It's a modified version of it, but the original code was of a movie where the gist of this whole statement is whenever we choose something to do or we do certain aspects of task in our code, first we always have to prioritize it. So whatever we do has to be impactful for the business first. Then if it's not a business call, it has to be a user call. That user has to see it, because no matter what you use under the hood of your code, user has to use it, right? So he doesn't care what do you use. Then when you are done with both users and businesses, then you need to check what the app needs, right? So basic flow is business, user, app, and then your team. So this is the sequence you have to follow whenever you think that you need to do something for the whole application per se for your company, something like that, right?
Yeah.
So till now, we were actually giving you more of just kind of a thing, what's happening, why you should do this and that stuff, right? Now, let me put on the Android developer hat on, and let's talk about Android now. So there's a tendency which we follow basically in Android. There's a sequence, if any Android developers out there can relate to. The first sequence, always the first thing we check is crash, but at a certain time we also see if a certain thing is deprecated, correct? So that's one of the things which we check. Then we have something called launch. Then what happens is when a library comes up, if something is deprecated, we have a replacement. It's a launch version of it. Then this comes the bigger part. We need to migrate it. So if the sequence, if you see, it's a deprecation, it's a launch, then migrate. This is the whole process a developer is involved in, right? Now, if we go deeper to this, deprecation. So there was a very good joke in 2021, if I have to put it that way. Like this year, the deprecate annotation was deprecated, right? So if you relate to it, if I say in a certain duration, if 15 deprecations have happened, then already a 20 set of new libraries or new replacement might be launched, correct? And what we basically say is, when we go from deprecation to migration, the involvement is not of just a developer. It involves a lot of time, and it actually takes a lot of effort to it. And for the efforts, you actually need to put time, right? So it's basically a whole circle which comes up. It's just not migrating anything to everything. It's just the involvement of time, and you need to figure out if that time is more important to try out new things in your application, or there is a user call or a product call, which is more important. So again, a time for a code that every library has to say, catch me if you can, because that's the part where you have a deprecation, right? Now, right? So now, okay, so this is our Twitter handles, I would say, but do follow us if you don't follow it. Just a self-promotion, but I think Niharika would explain more. Why do we put this slide in between?
It's like I can go both ways, like why you should follow us or why you shouldn't follow us. So yeah, I think okay. So moving on, I think more than this FOMO, there's a more popular word that is FOSSUM, fear of social media. I think everyone here can relate with it. As Jetpack Compose, yesterday we had the production thing there, so you can see many tweets around it, right? And this happens with every technology, or maybe your peers, your friends are doing or experimenting something. They just put on the social medias just to market that, and we all have this kind of fear, like, are we doing the right thing? Is my knowledge sufficient enough to just grab on the new things or not? Or should I be using this technology or not? So we all have these kind of questions, and social media has played a major role in creating that fear. But I would say one thing: just surf, just browse and see those tweets. Till the time you don't need anything, just don't get panic. You may be seeing like billion of feeds. We all are working. We all are like working for an organization for 10 hours. Then we have something for as a personal life also. Then we see all these feeds whenever we go on Android device and just our devices and just see the feed. So there'll be many launches, migration, deprecations happening every time. So just don't go with that. You will be whatever you are doing. So you just need to know that part in depth. That's it. That's enough for your learning part. As I have hired many of engineers who were just working on Java, and they have learned Kotlin after that because they had a good knowledge and the basic principles, the solid principles were clear, and they were following good programming practices. And this is all that matters. I know. So this is like our face whenever we are like, if we have to do something, like what to do, how to do, why to do. So trust me, we all are in the same boat. We all are on the same page. Everyone has this fear, even if we are just having this Google developer expert tag with us. Even we don't know everything about Android or and no one can know about anything, all the things about any domain or technology. So this fear has always made me to have this question, like, am I at the right place? Am I seeing the right thing at the right time? So till the time I figure out, like, if I am at the right place, I will hand over it to Himanshu to explain for the things which are in trend and which are creating fear for the developers out there.
Sure. Thanks. Okay. So if I had to put it in this prospect, right, there's a search trending bar which we have technically on Twitter. There are a lot of things trending. And if you have, right, consider this. I'll give you a very picturable answer. Yesterday was Jetpack Compose release day. And I've not seen a library in Android which has actually been on the trending page of Twitter. Jetpack Compose was, correct? Then we have some other trending topics like architecture, MVI, MVVM, MVC, MVP. So basically MVX, in anything, right? It can be anything. So, right, so there's one, KMM, something I definitely love. But this is also there. Then we have our everyone's favorite, Flutter, right? You might have Flutter that people would be like, should we do Flutter? Should we do KMM? Should we do native Android? What should we do? So basically, when you surf your internet, you would find everything, literally everything you don't know, right? So what I'm trying to say, okay, maybe I know Compose a bit. We have worked with architecture. KMM is new. Flutter, I don't know. But this is for someone who does know nothing. Maybe a fresher who's trying into Android, a 6-month experience guy, anybody. It can be anybody, literally. Basically, your Twitter feed, your Facebook feed, your LinkedIn would be added with inspirational quotes about something, to use something, but you will only see the things you don't know. So when I'm putting this, what I'm trying to say is, I do put something on Twitter that I have created this solution I want people to learn. But what I don't want you guys to do is just don't follow it. Understand, do you really need it? If you do need it, go ahead, learn this thing. It would never stop you, right? Because XML is never outdated if Compose is there. MVP is not outdated if MVVM is there. So my point is, do you need it? So with this, there's a very bigger question which is already there. What is the right place to learn, right? Like if you have to figure it out in that way. So what I would say is the best places which I can curate or I can think of is definitely Android developer documentation. And let me be very frank with you. Sometimes if somebody is starting off, Android dev documentation might be confusing or more of overwhelming for someone, right? So for them, it's the blog. Check out the blogs. See if that fits your situation, if that solves your problem, maybe. If not, check for an easier way, video tutorials. Because in video tutorials, you would need what to do, when to do, because that person is actually doing it. And if that's not the point, we have an open source projects. When you are done with this, you have tried something. There's an open source project where you can do it, right? You can learn something, you can. So example, if I have to be a very good engineer in architecture, I would rather go and check the glide code or the retrofit code. They're those super best ones. If I have to learn KMM, so even before this, John O'Reilly was giving a talk. Check his repositories. He has best KMM open source projects. So my point is, if you guys are learning, just check out some open source projects as well, right?
Yeah.
Now, so basically,
with our
cool.
learning, what we have learned is you can have different experiences. Maybe sometimes you love to read about something and then apply it, or maybe you love to watch. Maybe that person has created a video tutorial in an easier way. So it totally depends on you, what you love more. I am a person, I like video tutorials more, so I'll be watching video tutorials and maybe some open source projects, so I'll go for that. So always try to learn from your own experiences. People may say that these are some of the learning resources where you can find these ideas and products easy to be built, but it depends on you only. Like if you are a person who watches something more than reading, so you can go for the video tutorial. So
correct.
Yeah.
And just to add on to it, right? If you have to, like, if we are sharing our experiences here, what I want to put is, when I started in Android, I literally didn't understand the Android documentation, but now that's my go-to. In same way, if you find it hard, try some other source. If you find videos hard, try documentation. I assure you there are n number of things which are there. You just need to understand, right? So,
and one thing we missed is Google Code Labs, and I really found that like you can get that practical hands-on experience, so you can try that as well.
right. So the bigger question which actually pops up in everybody's mind, how to cope up with like the sequence of flows coming up. If what I wanted to give it a very bad joke, but just take it on. We are collecting something in our flows in the core routines. We are just collecting it. How do you use it? How do we cope up with the stream of data coming in, right? So again, a quote time. So my point is always, run behind the usability, excellence will follow, right? My whole point is, make your app as usable as possible for the users and just see how it grows. And by the time it grows, you would have a certain level of time to redo a couple of things, rebuild it, who knows? It's just that. And this quote was actually by Niharika herself. So I'm just saying.
From you or as well, like it's okay to say no if you don't know about something. It's not like everyone knows about everything. So if you don't, if as we are just talking about one thing, anything you are learning, just learn in that in deep, deep. That's what matters. So don't go for everything which is coming and which is in trend till the time you feel that necessity. And with necessity, we come up with one more thing, that is people often confuse between this necessity versus knowledge. uh, Anything which is necessary to be learned, or anything which we are learning just for the learning purpose, so we often get confused between these. Just to summarize, like, or some points which we have collected from our experiences. Anytime you are building something, you just need to check what a user needs. As we talked about the maintainability and performance, anytime you are building something, just see if something is really worth it to be added in your code or not, or you are just adding because your friend in his own company is doing that. So don't go for that. Check your user needs first, and if you are building the right product, and then start improvising that. Anytime, as eventually you will learn something, maybe you are getting some issue in your code, and you now there's a need to build something, to add something new. As I can tell you my experience when I was learning the unit testing part, so I got some, I started with not the TDD approach, I started with the unit testing. just writing the test cases when I already have the presenter and view model, just to learn how test applies. So at that time, my view model was not having the factory design pattern applied. So everything was just hard coded, any repository. So that time I learned about the dependency injection framework. So till the time you don't want something, just and also you don't you won't get to know the need actually, like why do we need it, that why part will always be missed. So just learn whenever you are having that need. Again, as there is a hype, so just don't go for over engineering. If someone has many companies are not using Dagger, right? And as we told, many companies are not using architectures as well. So again, just go for the parts which make your code clean and you are following the best practices and solid principles. Till the time you are following that, everything is good. And you can't cope up with everything, but anything, just know in depth, the reasons. Maybe sometimes what happens is you are not doing that thing efficiently, but that meets your code needs and your company needs. You just need to stand for that, and to stand for those technologies or frameworks, you need to know those technologies in depth. So just know in depth for them. And yeah, you are still doing great. You may be knowing 10% of what is happening around, but if you know it very well, and your code will look great after that. Okay, so we have many myths around Android, but there's a biggest myth which I have always got. I think you must when Marsha talks about it, I think you will be able to relate it, because I won't be able to talk about it. Yeah.
Okay. So even before starting all of these, I just wanted to put up one more point, which Niharika added. You are actually doing great. And when you need to see this, right, people start comparing themselves with others. Everyone in their capacity are amazing. Either it be you, either it be anybody else, or someone else in the team. You still, if you know what you're doing, you are just the best. Understand that point. Now, let's start. Myth, and that's the buster, right? Don't laugh if I say, if you tell someone, if a product owner or if a backend guy, if somebody comes up to you, says like, what have you to do? Like, do you have any tasks? You just need to call an API and you just need to show it. Android is like a front-end framework, right? Second thing which you say is like, cool, so what you have to do is, again, you just need to parse the data. And the biggest statement I've actually heard is there's nothing much to do in Android. It's just that you need to parse a data, and JSON parsing is Android. So this is a very big code which I got, right? Like Android is nothing but a front-end framework, a UI component, and just a UI parsing thing. This is everything Android is, right? And for God's sake, this is my answer to everybody. Android, not equivalence to front-end. Please understand this. And if somebody doesn't understand a layman term, right, I just give them this code set. I say them, okay, guys, you need to understand, folks. Android is not this. So what exactly is Android? We also need to take care of that part, right? So this is the biggest pain point, I would say. Android, 12,000 devices, done. We need to figure out 12,000 devices. On top of it, we have n number of versions. So when we build something, we start from Android 21. So it's 31 right now, Android 21 to 31. 10 versions we support, 12,000 devices. Again, it's more like a topic on top of it. We also has different types of OEMs, MIUI, stock UI, something amazing, correct? And the biggest pain, whatever you do, whatever you change, it takes time. If we were only a JSON parsing front-end framework, we would have done it in a minute or so. But when we release something, it takes time. At least for me, it takes maybe a day, 6 hours, whatever, but it's not real time. And everybody can relate to this. Every day, every month, every time you look up something, some other library, something is deprecated. So you also need to cope up with this. I totally understand this aspect. I don't know what to say, but this is Android for you guys. This is not an Android front-end framework. It's a whole ecosystem, a whole world in itself. So while we step
Just
towards wrap, yeah, please go ahead.
just to add one point here, like the OEM thing which Manshu mentioned. So trust me, when you go for Chinese ROM devices, you will find many issues there. The background services are not running. You are not getting notifications on time. So you can't really say Android is a front end development only, and you don't have to deal with many things. So people have to understand this. I think managers have to
Correct.
understand.
Correct. Okay, so we step towards the end of the talk. So there are a couple of FAQs which has been asked many times, literally n number of times. So there is a couple of FAQs which I want to answer it upfront. So Niharika, you want to take the first one maybe?
Okay, so is this the right time to choose Android? I think Android is, there's no right or wrong time, or I would say Android is not going anywhere. Uh, if I see the ecosystem, and also if I see the smartphones, people are like 70 or 80% are there. We have Android devices, and there is, if I talk about the job opportunities, if I talk about the communities we have where we can get help, everything is revolving around Android. Android has got a good community. So I don't think Android is going anywhere. So this is the right time. Anytime anyone asks me, this is the right time to choose Android, for sure.
Right. The next point, the next big question is either we should do Java or Kotlin. So everything is going Kotlin based if I'm to be in that point, but if you know Java, you can still pick up Kotlin. So if you're starting something, I would still recommend understand Java first, because that's the core of a lot of object-oriented like programming, right? So you can learn Kotlin, it's well and good. I would still say you need to learn Kotlin, but with Java, it's the first stepping stone for you in the whole ecosystem. So if you know Java, you'll pick up Kotlin very fast, but still you would have the Java knowledge with you. So it would give you that push to do something. So anything is perfect for you, but my recommendation would be Java.
Yeah, I still love Java. And I think with time we are getting wrappers over everything, and we are not getting to learn about how exactly the things are working under the hood. So I still, as Himanshu, I agree with Himanshu's answer. Like we should be learning the basics of everything. Even if like Compose is coming, I would still recommend knowing XML and then applying Compose after some time, after getting to know the success and failure from people. So you should know the basics. Okay, Kotlin versus Flutter. This is a kind of controversial question which have been asked many times,
And the
and as
debatable one.
and we are native developers, so I think Flutter is good to learn. There are many things which, like hybrid development, is providing you like lesser development time and efforts to give for any, as you can build for multiple platforms. But as I am working in Kotlin, and I can't see the same user experience till now with Flutter or even with React Native, which we have got with the native framework. And even if you have to work with the things OS provides you, the plugins, you need some plugins to be applied when you are working with Flutter or native, Flutter or React Native. But again, with Kotlin multi-platform is coming. So why do you need to learn any new language or if you just know Java, then you are switching to Kotlin, and then KML will provide you the native experience as well. So I'm just waiting for the iOS.
Correct. And one more thing, just to add on to this. If you're a startup, you want to build for multiple platforms in a very MVP way, go with Flutter. But on a longer run, if you want your users to have a stable experience, maybe choose Kotlin or the native experience, not just Kotlin, but a native experience. And we have our last question. Compose versus XML. This is the new one which has been asking. I would still say Compose is a new thing. It's stable, definitely yes. XML has to be your first thing. You need to understand the core, how UI works and how it has to be implanted in the phone, like how the phone UI works. And if you're comfortable with XML, if you have built something on XML, then maybe just pick up Compose and start working with it. Compose is definitely good to have, but not the mandatory one.
Yeah, and also even for the newcomers, just one thing to add, like even in the interviews, if you don't know Compose, that may be fine. But if you don't know XML, then there's a problem. So the companies are till now using XML, so maybe you just need to know the basics, even if you want to go for Compose or declarative thing in future with Kotlin and Compose. So, but yes, you should know about it. So, okay. Yeah.
Thank you so much, guys. This was fun.
Yeah, thank you. We really love to talk about this topic. Like we all have this fear, and discussing about the things which others would also have these kind of dilemmas. So we really love it. So thank you.
And this was completely unprepared, more of a conversation we were having, because this is a personal experience coming out of any Android developer.
So
nice. Thank you, Himanshu and Niharika. That was awesome. And I appreciate it's quite late where you are, so thanks for doing this. Yeah, it's time for Q&A, so more chatting, I guess. If we could get everyone back up. That would be great. Nice. So let's take a look.
Okay, I'll add the first question.
Will Compose replace
Standard way to code using Kotlin?
Lovely. Who wants to take a stab at this?
I guess,
sure.
Yeah. I'm happy to take that. Let me just put my headphones on. Sorry, getting some feedback.
Trying to think what the question I might have interpreted wrong. When it comes to Android development, from that perspective, like eventually Compose probably will become the standard way to build Android UI. And in fact, it's recommended that if you're building new apps now, if you're building new UI components, like to use Jetpack Compose where you can, because a lot of things we built with Compose in mind, and yeah, moving forward, it will be the way, probably the standard way we build UI eventually. However many years that will take for it to fully kill out the existing way, I don't know, but yeah, that's how I interpret the question. I'm not sure if anyone wants to add anything else there.
The next question we have is from Sitam. Is Compose View creating XML in the background?
I don't know the internals, but
well, I could probably answer this. So the XML itself, Android Studio generates code from it. So it's no, because so what's on your device isn't XML anyway. What's generated in APK is going to be actual code, and so Compose does the exact same thing. Sorry, I jumped in there.
That sounds good. Yeah, I was trying to. I think I interpreted that wrong as well, but yeah, no, that sounds good. Yeah, makes sense.
Awesome. Next question from Naman. Is it good to directly jump onto Compose with not so much experience in XML? John?
Yeah, absolutely. I think if you were, I guess it's down to how you interpret that as well. I suppose a little bit in terms of, I don't think XML is going to go completely away, and of course it depends if you're working in environments that, as probably Joe talked about, where you're sort of migrating from existing applications, and you still need to deal with sort of the crossover between sort of existing resources and so forth. But certainly in the Greenfield project, I think in terms of experience in XML, I guess if you put it that way, I think that's something you can certainly, I don't know there's necessarily a lot of learning involved there. I think there's certain XML formats for particular areas, for strings, for dimensions and so forth, styles, that I guess will be less dependent on it, I guess. But I don't think it's something that, I think if you were starting a new project today and you were hopefully using a Compose, you're probably going to be using a lot less XML. Hopefully, certainly you're going to be not using XML for layouts for a new project. Hopefully, maybe for existing projects, maybe. But yeah, I'm not sure if I've answered that well. But.
Cool.
I have a question on this, John. In addition to what Naman has already asked, so how quickly do you think the Compose will be adaptable in comparison to XML? Will it be a fast adaptation or will it take time?
Yeah, I mean, I've seen a lot of people are speculating about that. It's a hard one. I think we went through, I won't say exactly similar, but not too dissimilar transition, obviously, from Java to Kotlin a few years ago, and obviously a lot of projects are still using Java. They're still using if you look at the stats, I suppose it's kind of surprising, to be honest, actually, the number of projects in the Play Store that are still sort of, at least some component of them are based on Java. So I think that it'll definitely be a migration. I mean, I hope if you're developing a new project from scratch today that people would choose Compose now that it's stable. I think it's the right way to go. I think it's a significantly easier and better way to do UI development on Android than the existing approaches. But for most projects, for the applications I'm working on, for example, which are not using Compose right now, we'll talk a little bit maybe about where we can start to adapt it in certain ways, but it's going to be a relatively slow process, I think, to migrate over to that.
All right. Thank you, John.
I think from my perspective, I think in terms of UI development, Compose is definitely I guess I hate to use the word easier, but an easier approach. But I think what will be interesting is when it comes to things like the state management side of things. Like with Android development at the moment, XML and how we do things now, I feel it's we can just piece things together. It kind of works, and we could play around with things. But I think when it comes to Compose and state management, and it gets a bit more complex on that side of things, depending on the app you're building. But yeah, I think that's definitely where I took a bit more time to get used to it personally.
Where would we say that you should probably avoid if you're doing if you're trying to compose? If you're trying to do a new app, what kind of things would you say to avoid Compose for? If that makes sense. Or is it just good for everything?
I would say try and do everything if you can, and just try it. Try Compose first, and then if you run into difficulties or roadblocks, then there's no shame in using the UI toolkit. Whatever helps you move forward.
Nice.
Yeah. Just to add on this, what John said, if you're building something new, I would definitely recommend try Compose for almost everything. But for now, there are a couple of limitations to be used. Like not every library supports Compose out of the box. So at that point, if you're using some third-party UI library, you need to still use Compose injector with Compose. So that works, but try to use it as much Compose if possible.
Thank you, Himanshu. Niharika, you have something to say?
Yeah, one thing to add, I was talking to one of my friends, and they had a design library system already created for their own organization. So it really becomes difficult, to move to Compose for those people who are already created a whole design library system which the whole organization is using. So there can be major changes required. So we have to think that way also.
Yeah, but you can use the Jetpack Compose with existing XML that we are doing. So in a way, step by step, all of your components you can migrate to Jetpack Compose at some point.
Yeah, at some point, but yeah, that
I
will
mean,
be.
yeah, you can't just allocate like 1 month and come up with a new brand new library. It takes time to going from step 0 to becoming 1. So yeah.
Yeah, till the time they are not able to migrate, they won't be able to use Compose for sure. Uh, with that library. So, yeah.
Okay, a bit more of an open question next. Like, how do we overcome over professionalism?
Niharika, I think this is for you.
I over perfectionism. I think I have heard this word for the first time. But we have perfectionists and then over perfection. Okay, so I don't. Uh, there's nothing like, even I don't think perfectionism exists. Actually, we all are improving day by day. And again, as we talked in our talk, every point was emphasizing on you should be doing the right things in right way only. You should be learning, and we learn from our own experiences every day. We maybe getting some reviews from our seniors, or maybe we are reading some good open sources from people like in the community. So that way we cope up with the and cope up with this perfectionism thing. But I don't think like we are perfectionists in anything, and we can go for like over perfectionism. So that's a kind of again debatable thing.
I guess
Thank you, Niharika.
just add
Yeah.
one comment there, I guess, and this kind of comes up quite a bit, I suppose, in terms of general approach to, you're talking about sort of perfectionism in terms of someone's overall sort of general approach. But if you look at it from a project perspective, in terms of, ultimately we want to do is deliver code. We want to deliver functionality. The whole question. I mean, I sort of grew up in the software development environment where we had these 9-month, year-long projects where at the end of 12 months we would hopefully deliver something or send something. Obviously, we work in a very different world these days, and we are delivering code. We're pushing code every day. And I think that kind of touches on this a little bit, and sort of having a mindset that, because I see this with people I work with sometimes, that they struggle with maybe pushing incomplete code. It depends obviously what you describe as being incomplete, but working towards the idea of sort of incremental progress towards a point where you know that you're going to get to that point, and hopefully when you get to that point, all the sort of the dots will, or the I's will be dotted and the T's crossed, but just being comfortable that working environment, hopefully you're not going to be ideally hopefully pushing broken code. You're going to have tests. You're going to but to be comfortable with incremental progress basically, and ultimately getting to a point maybe where at the end you'll have got to a point where your solution that you're overall happy with, but being comfortable with being able to sort of in the intermediate points in time pushing incremental progress.
Thank you, John. That is helpful. I think I have myself experienced this when I was doing code development few years ago. So like if I added a functionality and it's not working as the way I expect it to work, it's like my code is not finished, and then spend hours over hours to make it like look perfect and then push it. So yeah, definitely understand that, Piragam. Okay, the next question we have is
We'll have this as the final question. Yeah, sorry, Mamta. Hina, sorry.
Oh, that's okay. How do
Should
you deal
I
with
go for this?
Yeah, of course.
Yep. So the
Could you
basic answer.
read the question out? Sorry, how do you deal with
Yeah,
deprecation if an alternative is not provided right away?
Sure. So I'll give you a best example of this in the current organization where I work actually. There are a lot of code which is deprecated, but it's not that mandate step that we have to just go up and have to replace it with something else. But the question is, if not provided, it's still okay to have a deprecation code unless we have an alternative for it, or we can build that custom thing for ourselves. If, for example, it's a third-party library or some smaller thing which has been deprecated, if we can manage to build it on our own, it's okay. Or else we can still keep on using it unless it's a hard reset that you have to do it now.
Yeah, might be a dumb question, but if we don't have alternative, can we deprecate something? Because deprecation means that you can't use that anymore because you have option 2. but I might be wrong. My understanding is that you deprecate something when you have alternative which is better than that. So in a way, when something deprecates, you have option 2 that you can start using. Yeah. Okay. I was just checking.
It could also be if you're removing some form of functionality, like maybe if an API has a search endpoint and your product's no longer going to support search, then they might deprecate that endpoint for clients to eventually remove. And if you're removing functionality, that could be another use case.
Yeah, that might be possible. Yeah.
Nice. Well, thank you, everyone.
We have one more question here.
Okay.
Sorry.
Okay. Let's go with that.
How does Compose work with architecture components?
I can give a quick first stab at that because I have a couple of samples that make use of those. So there is a sort of a navigation compose and navigation paging artifacts that are available now. But the navigation paging deals with the standard sort of paging library that's been built out, but it's sort of there's I can't remember the sort of extension function, but there's something that I think collect as paging. So, for example, one of the samples I have uses GraphQL and sort of GraphQL's ability to pull back pages. And once you have the sort of paging adapter set up, that Compose comes with this very nice extension function, like I said, I think collect as paging, and then that automatically manages your lists or fetching data as it needs to as you're sort of scrolling down through the list of data. And then obviously architecture components. I suppose the thing about the architecture components, maybe Joe, you probably comment maybe a bit more on this, but I mean, my understanding, I suppose, is this is where things are a little bit more distinct. I mean, I suppose the way I would have used the navigation components in an existing application with sort of the XML layout files and the associated APIs. Now, obviously, we have nav, this kind of nav host. There's a sort of, I guess, navigation in Compose, I think, is something that hasn't fully worked its way. I don't know that we've really settled on. There's certainly APIs that we use, but I think there's still an open question in terms of patterns that we need to use.
Yeah, I agree. I think that's well put. Like the navigation component's there to use, but there's documentation on it and there's like some guidelines. But for example, cases like modular navigation and doing navigation across different Compose modules, I think that's still something that people aren't really doing too much of at the moment. Like there is some support for it inside of the navigation component, but there's not really any like opinionated opinions on that just yet.
Yeah, and there was a very long, I don't know if people were following it, a very long thread in Kotlin Lang in the Compose channel over the last, I guess, today and yesterday around. This is another big open point in Compose, I guess, is how events are managed versus state and what we mean by events and state. It's a very broad area, I guess. And that touches on navigation as well in terms of how you manage navigation transitions in your application. If your view model is triggering the navigation, for example, to what extent we need to kind of coordinate between the.
Nice. Well,
thank you, John.
Thank you, everyone.
Thank you, everyone, for joining us today. Sorry for that kind of break it again. Go ahead.
No. And saying the goodbyes. It's okay.
I think we have a little lag on the video, on the audio and the video today. Someone speaks and it comes up later. It's happening quite frequently now. So thank you, everyone. Thank you so much for joining us this evening. And for all the viewers, the talks will be recorded and they will be uploaded on the Dev Party YouTube channel. If you have missed or you would like to watch it again, you can watch on the channel. And if you have any questions, you have the Twitter, handlers for all those speakers. You can reach out to them for any questions or any suggestions, ideas you want to discuss them. So thank you so much, everyone. Have a great evening, rest of the evening, and bye-bye.
Thanks, folks.
Thank you.
See you later.
Bye-bye.